What is a step-down transformer? Step-down transformer are used to decrease the voltage incoming loop to the site by increasing the electrical current, converting the high incoming voltage in the primary winding to the necessary lower voltage in the secondary windings. It can be looked like this or can be seen like these symbols. In this video, we will go through the working and deconstructing of a step-down transformer by starting to its function. The basic working principle of a transformer is simple. To begin with, these transformers are crucial components in electrical power systems. Its function is used to convert electrical energy from one voltage to another. It does by converting the high incoming voltage in the primary winding to the necessary lower voltage in the secondary windings as mentioned earlier. Step-down transformers has a different parts that plays a vital role in working principle of the transformer. But first, let's proceed in the constructing of the transformer. Warning: the following video contains material that may be harmful and don't try this at home. Please be guided by the elders. Deconstructing a transformer requires a deep understanding of its components and their roles in the model. By following these steps and being persistent, you can gain valuable insights into how the transformer works and how it can be improved. First, disassemble the transformer. Begin by carefully disassembling the transformer to its individual components. You may need to use tools such as screwdrivers, pliers, and wire cutters to remove the wires, screws, and other fasteners that hold the transformer together. Second, remove the winding wire. Locate the winding wire on the transformer and remove it carefully. This may require some patience and precision as the wire is often wrapped tightly around the core of the transformer. Third, separate the core. Once you have removed the winding wire, you can separate the core of the transformer. This is usually made of a ferromagnetic material such as iron and may be in form of laminated core or a solid core. Next, remove any insulation. If the transformer has any insulation material, such as paper or plastic, between its layers, remove it carefully. Then, reassemble the core. Once you have separated the core and removed any insulation, you can reassemble the core if desired. Depending on the original design of the transformer, you may need to restock the laminated core or reform the solid core. Lastly, rewrap the winding wire. If you want to create a functioning transformer, you will need to rewrap the winding wire around the core. This will require careful attention to the number of turns, the gauge of the wire, and the orientation of the windings. The process of reversing the making of a transformer is likely to be complex and challenging, and may require specialized knowledge and equipment. It is important to exercise caution and beware with the execution of uncertain procedures. Different parts of transformer and their functions. First, the primary and secondary winding. The primary winding, this is the input coil of the transformer, which is connected to the high voltage power source. The primary winding is responsible for creating a magnetic field when an alternating current flows through it. While secondary winding, this is the output coil of the transformer, which is connected to the load. The secondary winding receives the magnetic field created by the primary winding and produces a voltage in proportion to the turns ratio between the primary and secondary windings. Core. This is the magnetic core around which the primary and secondary windings are wound. The core is usually made of laminated iron or silicon steel and serves to concentrate the magnetic field produced by the windings. Insulation. This is a layer of insulating material that separates the primary and secondary windings, preventing electrical current from flowing directly between them. Insulation also helps to protect the transformer from damage caused by the electric arcing. Switch used to control the flow of electrical current in a circuit, while transformers are used to change the voltage level of an alternating current or AC signal. Fuse. Use of fuses in transformer circuit will depend on the design and application of the transformer, as well as the specific requirements for overcurrent protection in the electrical system it is a part of. Enclosure. Cover in a transformer is to provide mechanical protection and insulation to the transformer's component. The cover is typically made of a non-conductive material such as plastic or rubber and is designed to prevent accidental contact with live electrical components inside the transformer. Core laminated sheet E&I silicon or iron steel. The laminated iron core prevents the formation of eddy currents and thus reduces the loss of energy. The core is laminated to reduce this to a minimum as they interfere with the efficient transfer of energy from the primary coil to the secondary one. Bolts and nuts. Bolts and nuts are used to hold the various components of a transformer together, providing structural support. They help secure the core, windings, and other parts in their proper positions, ensuring the stability and integrity of transformer's construction. Power outlet. Transformers are often used to step down voltage levels for residential or commercial applications. The output of these transformers may be connected to power outlets, commonly referred to as sockets. Power cord, also known as the input or primary cord, plays a critical role in connecting a transformer to the power source and enabling the flow of electrical energy. Now, let's proceed to the calculations of different ratings. We have a given voltage input equals to 220V, voltage output 110V, primary coil 560 turns, secondary coil 550 turns, length of the core 2.7 cm, width of the core 3 cm. First, let's find the turn ratio. The formula of the turn ratio is equals to NP over NS. 560 turns over 550 turns is equals to 1.018181818. Next, let's find the voltage ratio. The formula of the voltage ratio is equals to BP over BS. 220V over 110V is equals to 2V. Next, let's find the current ratio. The formula of the current ratio is equals to IP over IS. First, let's find the value of IP and IS. IP is equals to rating over input volt. 150 VA over 220 V is equals to 0.6818181818A. The formula of IS, rating over output volt, is equals to 150A over 110V is equals to 1.363636364A. Substitute the value of IP and IS to find the current ratio. 0.6818181818A over 1.363636364A is equal to 0.49999999. Then, find the power ratio, PP over PS. PP is equal to input volt times primary current, 220V times 0.6818181818A is equals to 150 VA. PS is equal to output volt times secondary current, 110V times 1.363636364A is equals to 150A, which is equal to the given value of volts in the transformer. Substitute the given value, PP over PS, 150A over 150A is equals to 1 watts. To find the impedance ratio, the formula, Zp over Zs. Find first the Zp and Zs. Zp is equals to Bp over Ip, 220V over 0.6818181818A is equals to 130.8108108 VA. Zs is equals to Bs over Is, 110V over 1.363636364A is equals to 80.66666688 VA. Impedance ratio, substitute the value Zp over Zs is equals to 130.8108108 VA over 80.66666688 VA is equals to 2,984.66714. And lastly, to find the core area, length times width, 2.7 cm times 3 cm is equals to 8.1 cm squared. I hope you learned something in this video. Thanks for watching.